Okay, this video is going to cover the endochondral bone formation, the fractures, and the ending of this section. Endochondral bone formation is talking about all the bones that start out as hyaline cartilage and that are converted into bone tissue. So arms, legs, hip bones, that kind of thing, vertebrae. It says most bones of the skeleton are endochondral bones. They develop from masses of hyaline cartilage shaped like future bony structures. Now I know this has got a blank here, but what you want to do is you want to go up to that, and this actually is found in both. I don't know. This might be a little better to use. Which PowerPoint has the bigger picture? Oh well, this will work. So this is a cartilaginous model. Now, believe it or not, arms, legs, hips, they start out looking like this. And early in development, the periosteum, which is a layer of connective tissue that surrounds every bone externally, starts to form here. Now, beneath that, what ends up happening is hyaline cartilage has, if you remember from histology, chondrocytes. Chondrocytes sit in little depressions called lacuna. And there's a point where those chondrocytes will start to get large and grow out of the lacuna and start to degenerate. And what happens there is you have different kinds of osteocytes that will form there. You have osteoblasts and osteoclasts that will move in and start forming bone tissue. Now, that area in a long bone is called the primary ossification center. It starts in the middle and bone formation continues toward the edges. Osteoclasts form the medullary cavity as a bone is developing, and then osteoblasts are depositing compact bone on the outside areas of that. So you can see as the age is progressing how more and more the bone is converted. At some point, a secondary ossification center will form in long bones in the epiphysis, and the outside layer stays hyaline here, and then these layers actually stay hyaline, but then these other areas start being converted into bone tissue. That's what osteoblasts do. So this would be like the femur of a kid up until their teenage years and even early adult, possibly. So what ends up happening, you have a layer of hyaline on the outside of these long bones that's called articular cartilage. You can see it there. But then what's left are these epiphyseal plates or discs, and those are bands of hyaline cartilage. That's what's left of the original hyaline cartilage model. Now, growth hormone helps sustain these epiphyseal plates and keeps the cartilage cells active. And as long as they are present, that means that this bone is still increasing in length. At some point, and this happens to everybody's going to reach their height, and that has to do with genetics and a lot of different things. But at some point, those epiphyseal plates will be converted into bone tissue that become ossified, and at that point, that person's not going to grow any taller in height. So a person that's super tall, they had growth hormone in sufficient amounts for a longer period of time, or their bones grew faster. But that's a real quick overview of how endochondral bones will form. So the primary ossification center occurs in the diaphysis. This actually occurs in the epiphysis, and you can just refer back to that picture. It describes everything pretty well. In a long bone, the diaphysis is separated from the epiphysis by an epiphyseal plate or band of hyaline cartilage. Bone increases in length at the epiphyseal plate, and its presence indicates that bone length is increasing, like I had mentioned. So as long as those little growth plates are there, that person is still growing in height. When they're gone, that person is no longer going to get any taller. As far as growth of bones, what are some factors that affect that? Now, I would encourage you to go, this is the textbook. This is showing what an epiphyseal plate looks like, and basically bone is being added. But let me see, is it up here? Well, let's go to the other. We'll go to the other tape. How's that? Here we go. Here are some factors that affect all kinds of bone development, repair, that kind of thing. So nutrition, calcium, vitamin B12, that allows calcium to be absorbed from the blood. Vitamin B12 is actually called intrinsic factor. Anyway, calcium. Vitamin D is also very important. So going out in the sun, also getting that from the diet. Hormones, testosterone, estrogen. Testosterone is the male primary sex hormone. It does affect bone development, makes them develop. Estrogen actually makes bones ossify sooner. That's why females, on average, are not as tall as males, because estrogen in high amounts will cause those growth plates to disappear, the epiphyseal plates. And then growth hormone actually maintains those epiphyseal plates. So a person that has a lot of growth hormone in their system could, well, if you have too much, you end up being tall, 7'5" and above. And physical exercise makes bones more dense or thicker. So, bone disorders. All right, so here's a simple fracture. That's just a broken bone that protrudes through skin. Here is a compound fracture is a bone that's broken and it's protruding through skin. I actually have a picture for one of these. So all these other bones are actually, they're simple fractures, but they also have, you can have a simple fracture that has different terminology with it. That's what all these others are. So, sorry, we're going to go here. So this is called a green stick fracture. You see how this part is broken and then this part is still attached. This happens with children. Remember, children's bones have more collagen than adults. Adult bones are more rigid, and so when they break fully. It's kind of like an old tree limb kind of thing. Whereas a green stick's like a green tree limb. It doesn't break off all the way. This is a fissured fracture, which is an incomplete break. You can see it's not broken, but it's like a stress fracture. Comminuted fractures, when it shatters like this, remember there's a periosteum around that, so it's going to keep all this together unless the periosteum also is damaged. That's a comminuted fracture. It's a fragmented bone. This is called a transverse fracture because you have a right angle here that it creates just to break across the bone. This is an oblique fracture. You see how it occurs at an angle, and this would actually protrude through skin. And then this is a spiral fracture, which occurs with the wrist and ankle bones. Person steps and their foot stays in one place and their body turns. They can twist it off. Sounds really painful. So I used to work in a hospital, and I stole a few pictures from their database. I didn't steal them. They let me have them. But yeah, and that's a guy with a steak knife stuck in his skull, which amazed me to this day. It was in the back of the skull behind his brain, so it didn't really affect him that badly. But here's a compound fracture. You can see it's broken. That's a lower leg bone protruding through skin. Here's also a compound fracture. This person was catching a football, and they threw it, and it broke their finger, and the bone's sticking through their skin. Ouch. This is a comminuted fracture. That's a shattered femur where it's fragmented on the end. This is actually an x-ray. Oh, I forgot about this guy. This is a guy in Midland, Texas. He fell off a skyscraper, landed on his feet, and that's his femur up here where his hip bones are. So his hip bones are here. His femurs actually ended up in his hip bones like that. And this is a surgery to go back and try to repair all that. His femur was broken and it was shoved up into his hip area. This is a spiral fracture. This is called a tib-fib fracture where it's twisted off. This is an oblique fracture. So these are the lower leg bones. This is a fibula. It's kind of a weird angle. That's a tibia. This is a rodeo clown. The bull took out his lower leg. You can see it's broken at an angle. This is actually a bone infection. It's called osteomyelitis. And where we are, these were all the fractures. A little out of order, but osteoporosis is where you have porous bones. The osteoblasts actually slow down. And this happens to females. It happens to males too. But at menopause, estrogen secretion goes down, production. So the osteoblasts are not as active. The osteoclast bones that absorb bone, they stay at the same rate. And so a lot of times osteoporosis is basically porous bones that break easily. Osteomyelitis is a bone infection, which is what that is. That's a staph infection in bone. Bad thing to get. Can't get rid of it. They have to amputate a lot of times. This is rickets, which are soft bones. As a baby, person doesn't have enough calcium in their diet, or vitamin D, or vice versa, and all those, or vitamin B12 possibly. But it's all related to calcium. The inorganic part of the bone matrix does not have calcium, so they're not rigid. So you end up with these deformed bones like that. The bowed legs is a sign of that. That used to happen a lot back in the early 1900s. There's osteoporosis. Now, scoliosis, kyphosis, and lordosis. These have to do with the spinal column. An abnormal lateral curvature is scoliosis. And this hunchbacked appearance like that is kyphosis. Can happen with osteoporosis. Smaller females, and it can happen to males too, but just because of the estrogen part, you may see it more in females, but that's an accentuate, the thoracic area, you have this hunchback appearance. This is an accentuated lower curvature of the spine. It's called lordosis or swayback. And it's kind of showing the green is the normal sort of path, and then the red is showing what's called the pathological. Last thing here, and some body movements. As far as parts of the skeleton, let me cover that real quickly with you. This is a great picture. The orange is the axial skeleton. The yellow would be the appendicular. Axial skeleton is the cranium here, sternum, ribs, and you see how they're connected by cartilage, and then in the back, the vertebral column, sacrum coccyx. All that is the axial skeleton. The appendicular starts with the shoulder girdle, which is the clavicles and scapula, and then the hips here, hip girdle. And then the arms and legs. So you have the humerus, radius, ulna. Now remember, the radius, the lower arm bone, is on the thumb side. The ulna is on the inside where the pinky is, pinky side. Femur, and these are called the os coxa bones or hip bones. Now the femurs, patella, tibia, fibula. Tibia is the shin bone, medial. Fibula is the smaller bone, lateral. And then you also have, I didn't do this, carpals, which are the wrist bone. You have metacarpals, which are the bones of the hand. You have tarsals, which are the ankle bones. You have metatarsals, which are the bones of the feet. And then the actual fingers and toes are called phalanges. The thumb has a proximal distal phalanx. It only has 2 bones. The 4 fingers, the other fingers, have a proximal middle distal phalanx. Same thing with the big toe. The big toe has a proximal distal phalanx, only 2 bones. And the 4 other toes have a proximal middle distal phalanx. They actually have 3 bones each. Last thing. Now, these are body motions, and if you're learning muscle, this will help you. These occur at different planes. It says synovial joints, which they have a synovial membrane, so you're talking about the major joints of the body. But these terms are good to know. Extension, flexion. Extension is increasing a joint angle. Flexion is decreasing a joint angle. So this person here, and I'll probably just stay here. Here is extension. See how the angle's increased. Here's flexion. So when this person has bent their leg up, see how the angle is not as decreased, not as wide. Here's abduction, adduction. Adduction is going toward the midline or adding to the body. Just think of add. Abduction is moving away from the midline. That happens with shoulders and hip, so the arms and legs can do that. Dorsiflexion, plantar flexion. Dorsiflexion is pulling the foot up. You see the leg is stable. Plantar flexion is moving the leg down. This is a term. This is inversion, which is when the sole of the foot is pointed toward the inside. This is eversion, where the sole of the foot is pointing out. You can actually see that on people's shoes sometimes, how they wear them down. Some people are over everters or inverters or pronators. We don't really do protraction, retraction, or this one. Bill Cowher is an old coach for Pittsburgh. He was stuck in permanent protraction where your jaw sticks out. Circumduction is where you can take a shoulder or hip, a ball and socket joint, and you can do it in a circle like that. Supination, pronation. Supination is taking the palm of the hand, and the lower arm bones can do this. They can cross over, and turning the palm of the hand up. Pronation is turning the palm of the hand down, like that. That's supination, that's pronation. So those are some really common terms. We don't really do the others. So look at these, good matching exercise, and I hope this helps. And we've run out. We have an extra page. I now know how to get rid of those. It's called control backspace. If you ever run into that and you can't get rid of a extra page in a document, you click on the page and do control backspace. So, all right. Well, thanks for joining me.